Hello everyone, my name is Ali Pei. I work for J2 Global. My presentation today is about OpenSIPS. I just have a couple of questions. I would like to get a feeling of your experience with OpenSIPS and proxy servers. So how many people here have already used some sort of proxy server or SPC? How many would like or are considering using a proxy server? And then how many don't have anything to do with proxy server? Okay. So today I'm just going to talk about proxy servers and OpenSIPS. Sorry, I work for J2. We do cloud services for businesses. We have fax, online fax, voice, email marketing, a bunch of online services. So if you're interested, please go to j2.com. My topic today, I'm going to talk about proxy servers, and specifically OpenSIPS. So I'm just going to go through history of VoIP, and then talk about proxy servers and why you need proxy servers, and talk about OpenSIPS, and then hopefully have enough time to talk about redundancy and distribution. Feel free to ask questions anytime you have questions, and I'll do my best to answer. So history of VoIP. Well, started a long time ago when people started talking to each other. And then it actually started in 1892 with the first phone call. And back then, telephones, they needed cables. They still do. There was lots of cables. The phone companies, there's like thousands of cables coming in and going out. And then, but the cabling, it just never went right into your phones. They always had distribution panels that, the cables come in. They used to call them MDFs and things like that, which all the cables from your phone companies would come in and then go out. So this was a common practice. And with the legacy phone systems, analog phone systems or digital phone systems. And then, in fact, this sort of practice, like distribution panel and terminals and all these things, they're not just a voice thing or a telephony technique. It's like in networking, and it's used in a lot of other technologies. Like in IP, you have firewalls, routers, NATs. For ISDN or digital phones, there was the ISDN gateways. For electricity, there are distribution panels. For water supply systems, again, there are like similar concept. And even like airports, there's the same concept exists in the airports. You just go in, you go through a security, you go in this transit area, and then you go to your gates, you go out, and if one gate is broken, you might go to the other gate. But it's the concept of like an airport is a proxy server. Everybody goes in, and then they're dispatched, or vice versa. So the concept of a proxy server is not something new. It's not just for VoIP, and it's always been there. But when it comes to VoIP, you need a proxy server to do the same thing. And OpenSIPS is an example of what you can do. So, chapter 2, proxy servers. Some call them, based on if you look at RFC 3261, is that SIP RFC? There is no such a thing as SBC. SBC is just a commercial word. Technically, it's a proxy server, but different people call it different things. Some call it SBC, some call it back-to-back user agent, some call it SIP router or load balancer, but they're all the same thing, the same concept. It's a proxy server. And then, so why do we need a proxy server? The first advantage is improved performance. So if you have your traffic instead of your traffic going right to your Asterisk, first it goes to your proxy servers, and then your proxy server can do security checks, drop messages that are irrelevant, block attacks. So before the traffic gets to your Asterisk servers or gateways, it gets processed and processed and vetted. So that improves the performance. So your Asterisk servers don't need to do a lot of things, like a proxy server, OpenSIPS server can look after registration, authentication, or examining the SIP packets or source IP addresses and things like that, or add, remove headers, or change IP addresses, do NAT traversal. So that all helps to the performance of your environment. And then also it can provide redundancy. So if one of your Asterisk server goes down, it knows, it routes the call to the other one. Or if one of your carriers go down, or you talk to different carriers, it knows about all these carriers. You have rules. You say, if it's an international number, use this carrier. So you have all these control over your traffic on both directions. And that helps your performance, increases security. It gives you flexibility. And then, so there are numerous features that you can have once used when you have a proxy server. So again, you can do load balancing. Let's say you have 10 Asterisk servers or 5 Asterisk servers. You can load balance the calls, or you have 10 trunks, and then you can also specify how many channels each trunk or each of your gateways can handle. You say I have an old Asterisk server, can only do 200 calls, but this one can do 400 calls. Or this one can do voicemail and, IVR, but this other one can do fax as well. So you can specify your resources, and then you distribute the calls accordingly. Also, if one of your Asterisk servers you want to do maintenance, you disable it on your proxy server so it doesn't route any more calls. Basically goes to the drain mode, and then when there's no active calls, you can do your maintenance, bring it back online, make some test calls, and then enable it and starts accepting traffic. And you can do SIP signaling, codec and digit manipulations. For instance, some carriers send +1 in front of the number, your Asterisk doesn't write, or vice versa. You can take care of all those. Or some carriers need a +1 in front of the number, and some they don't. You can do all that within your proxy server. And then, or you can add headers, remove headers, and that sort of thing. Control your rates, like if some trunks can only handle like 20 calls per second, so you can control, because if you have 10 Asterisk servers, you can't really control how many calls per second, because different Asterisk servers are making calls to the same carrier. But when they're going through the proxy server, you have control, and then you can reroute or use an alternative trunk. And also for media, you can either do direct media. So a proxy server only looks after your signaling. It controls the calls. It doesn't look after your media, but you can either do direct media. So if you have, I'll show some diagrams later, but basically the signaling can go through your proxy server, but the media can still be direct from your Asterisk servers to your carriers or your SIP clients. And but if you want, you can use a RTP proxy or media proxy server and proxy media if you don't want your SIP phones or carriers talk directly or forward directly the media to your gateways. Now I'm going to talk about your different choices if you want to use a proxy server. So there are a bunch of commercial products out there. They can get quite expensive. Like you'd be spending like $250 million for an Acme packet SBC. Or you can use open source proxy servers. You guys are here, obviously, fan of open source, otherwise you wouldn't be in AstriCon. So with open source, first of all, it's no cost, no license fees. You don't have to worry about, okay, like if you buy a commercial packet, they sell you 800 channels, and if you want to expand, you always have to buy more licenses. If you need more features, you have to pay license fees for those features. And they have like numerous different licenses for different features. And then, but open source, none of that applies. And then on top of that, you have flexibility, and because you can customize. With the commercial SBC, they have 1,000 features. You only need 22 features, but the features they support, they only support 20 features of the 22 features you need. So like, there's something you want to do, you can't do. But with open source, it's flexible, it's open. You can just make your own changes or ask the community to change it the way you want it to work, or a specific feature that you need in your deployment is something you like to see, and it's not there, it's easy to do. And you're not relying on one company. A lot of phone companies go down, so if you rely, let's say, on Dialogic, for instance, and then if Dialogic go bankrupt, you're toast. It's not easy to migrate from one platform to another platform, but open source cannot go bankrupt because it's just out there. Like even if the core developer leave it, someone else will pick it up and continue. And at the end of the day, you have the code. So it gives you're not depending on a single company, and there is a community. So there is a wider support. People that are expert. You can get help from for cheaper in different countries, different area, and at the end, that's the future of telecom. Everything's becoming open source. So now I'm going to talk about OpenSIPS. So OpenSIPS is a proxy server. It's a high-performance proxy server. It's really lean. It's a great product. Before I forget, we have an OpenSIPS summit every year with AstriCon and ClueCon. So this year was on Tuesday. So if you're planning to come back to AstriCon, always look for OpenSIPS summit as well and attend the one-day conference. And so OpenSIPS, there are numerous things you can do. There's very little thing that actually you cannot do. Anything you can think of, you can do. And once you actually start using a proxy server such as OpenSIPS, after a while you're going to think that, how did I live without it? It's impossible to not having a proxy server. And how many people here that are using or start using OpenSIPS and have this feeling that, how did I live without? How can you do without a proxy server? It's impossible. Like numerous problems that once you have a proxy server, all of a sudden everything simplifies. Just like your life changes. And then so call routing. You can do call routing. For instance, all calls are coming to your proxy server, your OpenSIPS servers. You can define rules, set priorities, do list cost routing, look at reporting. So basically, you can route your calls on whatever direction. You can do NAT traversal. How many people here, they put their Asterisk servers or media gateways on public internet? Bad practice, right? You don't want to do that. But if you have a proxy server, you just put it on your local LAN. It's not reachable. And your proxy server, your OpenSIPS, can do the NAT traversal. It can use the public IP address what it needs to, and vice versa. And security, again, for the same reasons, all your gateways are behind the proxy server. You can do numerous validation on your incoming invite request. You can examine source IP address, the number, the pattern, the, like for instance, if you have a SIP client, SIP phones that you sell to your customers, you can, when you do configuration, you can configure all the phones a bit different, like have a header or a specific user agent. And when the call comes in, you check for that header, see if it has that version. And if it doesn't, then you just drop the invite request. That all of a sudden eliminates, 99.99% of the hackers. Because who knows that you have that low header there. So you basically can look for things that's specific to your environment and not necessarily random people know. And then you can look at that. It says if the call comes in and the user agent is not this and this, or if the domain is not this and this is not my customer. Just dump that packet, don't respond. Because if you respond, then they know that there is a proxy server or a SIP server there. And then registrar server. So how many people here use more than one Asterisk server in their environment? So where would your phones register? Asterisk 1 or Asterisk 2? But if you have a proxy server or OpenSIPS, that's your registrar servers. None of your phones need to register to Asterisk servers. They all register to your proxy server. So it improves your performance. Your registration is at one location. Your failover scenarios is quite simplified. And it's far less complicated. And then you can do SIP signaling, codec, digit manipulation, different carriers, different gateways, different phones, they do things a little differently. And you can look at those headers, those values, and change them on your proxy server before you send them to your different gateways. You can do load balancing. Again, we talked about it. So like if you have 5 Asterisk servers, you can assign resources to each Asterisk server. Say this one can do 200 channel fax, 400 calls. This one can only do 50 calls. This one can do outbound, and so on. And then when a call comes in, OpenSIPS looks at the resource that needs for that call and sends it to the least busiest server. And then on the OpenSIPS server, you can see how many active calls are in each server. So you can get proper reporting at one location. And you can disable, enable, change channels, and gives you a whole lots of flexibility. Failure detection, rerouting. So if it sends a call to a carrier, the carrier doesn't respond, your SIP trunk is down. You set a timer 4 seconds. So if it didn't respond 4 seconds, forget about it. Send it to the next trunk. And then and if it doesn't respond, then mark it disabled. Next call, forget about that carrier until I manually enable it or ping it every 30 seconds. And if it responds, then I start routing calls there. Or you can have rules for least cost routing or quality-based routing, profit maximizing routing. So least cost routing doesn't solve all the problems because there are various variables within routing rules that some trunk offers better quality or less quality. So you can have gives you a lot of flexibility. Scripting. So if there is a logic or a rule or something you want to do that is not already implemented in OpenSIPS, you can write that logic with Perl, for instance, and then just call Perl from your script and then do your logic and then return like true, false, or gateway number and sort of that and do the routing. And everything, all the configuration is in a database. But if your database goes down, your OpenSIPS keeps going. If you make changes to your configuration database, you don't need to restart OpenSIPS. You just say reload. It reloads the tables from the database. And you have a management interface that you can get reports, see active calls, change rules, and help for all the different modules. OpenSIPS overview, so performance, you can do 60,000 calls per second in 1.11. So they just made some memory management improvements. So that's huge. I don't think any carrier can ever do 60 calls per second. And it can also do 5 million simultaneous calls, or 20 million, something like that, either 5 or 20 million. And it has distributed architecture, so you can have multiple OpenSIPS servers, and using bin interface, they replicate the dialogues amongst them. So if one goes down, the other one knows everything about those calls, and they can actually be in different locations. And there are over 120 modules. OpenSIPS.org. Again, we have summits every year, the day before or after AstriCon or ClueCon. And then there is a learning curve. So OpenSIPS or proxy server, if you get the concept, if you know what you're trying to do, then you have to spend some time. It's not fastest due to dial tone. It's not Asterisk like, oh, you can get working in 4 minutes. No, you have to know what you're doing. You have to read some document. You have to understand what you're trying to do. But there is lots of help. There are mailing lists. There is, the summits, the forums. There is consulting. You can ask for consulting, or you can projects that can be done with the OpenSIPS team. And but yeah, there is a learning curve. So I'm going to talk about the modules for a bit. I want to have 5 minutes for questions. I only have 10 minutes left. So we have to finish at 3, right? Okay. So maybe have questions. So modules, there are 120 modules, but I just have some of them here. So there is a registrar server module. So if you, in your environment, you have SIP phones or SIP clients in any sort, TCP or UDP, whatever, they need to register somewhere. You load the registrar module, and it looks after your registrations. Authentication, presence server, instant messaging, NAT traversal, back-to-back user agent. If you need to do back-to-back user agent functionality, like the calls come in from this company, you want to send it to the other company, but you don't want them to see each other, use back-to-back user agent, and it's basically back-to-back user agent. And you can, different database modules like MySQL, Oracle, like I use ODBC to connect to Microsoft SQL. And so whatever database you have, like if in your company you're using, let's say, Microsoft SQL for your .NET application, and that people can log in and sign in and change their password greetings and stuff. OpenSIPS, you can hook up your OpenSIPS to the same database and just have one database that's backed up there, it's redundant there, and so you don't need like different databases and things like that, and then everybody accesses the same data. Like for registration, all your usernames, passwords, or whatever, it can be in the same database, and then you just tell OpenSIPS, you get where you get your usernames, where is the password, and how you authenticate, and that kind of thing. And then for trunks and routing, there is dynamic routing module, which is a prefix-based rule routing module. Based on, you set rules based on priority time distribution, like from 9 to 5 p.m. go here, 5 to weekends go here, and those sort of things. There is a load balancer module, there's dial plans, SIP message operations, and so on. For and there are some utilities like rate limits. So if you want to say, don't send more than 20 calls per second here, or gives you statistics like how many, if you have a call center or call queue, if you load the call queue module or call center module, then it can show you how many calls each agent has been answering, what was the average of call and things like that. It does diagrams. SNMP SIP trace is like Wireshark or TCP dump, but it dumps all the traffic in a database. It's great for debugging. And then for accounting, you can do the CDR. So if you have 10 Asterisk servers with OpenSIPS, you can capture all CDRs at one point. And then so you don't need to do CDRs from 10 servers and try to put them all together in one database. It can come one location. And I just forgot what I was going to say. And then lastly, I'm going to talk about the redundancy in distribution with the OpenSIPS. So basically, if you're using Asterisk, this is your first basic setup, right? You have a Asterisk box there, which is your PBX. You have some SIP phones or SIP clients, either in your local network or on the public internet, and you're hooked up to your carrier through some SIP trunks. And hopefully you have some sort of NAT firewall in between for security. The problem is that if your Asterisk box goes down, then you're pretty much toast. Your whole telephone system is dead. And so here I added, so you might have analog and digital gateways or analog digital phones, but they're all relying on that one box. So if you want to have redundancy, that's when you need a proxy server, such as OpenSIPS, and then you'd have a database, so you can store all the configuration, states, dialog things on the database, and then you would have like 2 Asterisk servers. So in nodes, it can do distribution, load balancing, or you can have multiple trunks. So if one fails, the other one is working. If you need to add another server to handle more traffic, it's simple because you just, in your proxy server, you say, now I have 3 servers and this one has 200 channels. So it looks after load balancing. And so it gives you, you're now not relying on one server. However, if your proxy server goes down, again, so you definitely want to have at least a redundant pair of proxy server. So if one goes down, the other one will become active. So it can be active as standby or active. And again, you can know which trunk is up and down, the load balancing roles and all sorts of things that we talked about. But then if more of a a cloud solution, a bigger network, you actually might have groups of servers, not like 2 or 3 Asterisk servers. You might have a bunch of Asterisk servers here that do IVR, and then you have groups of media gateways here that do call center or do fax, or you have a QA department or dev department. So they all can be groups of servers that sit with on your behind your proxy servers. So all the and you configure the groups and proxy servers. So when you say load balance this call to my fax servers, and then so the OpenSIPS knows you have 5 fax servers, and it knows how many active calls on each server, and then it will send it to the least busiest server. And again, all the proxy servers would be redundant. They'd be aware of each other, and if one goes down, they can all be, active, or active as standby configuration. Your database would be redundant. They can again be master-slave or master-master redundant. And this diagram here should cover pretty much everything that you guys are doing here. Is there anybody that doing something like in their network, they're doing something that I haven't included in this diagram? If it is, let me know, and sure, what is it? Yeah, it's not included in this diagram. Do you have something in your network that is not included in this diagram? because I try to keep this updated. And that concludes the presentation. We have about 3 minutes for questions.
So, with all what you just said, just basic question: why do they need a PBX?
What's that?
Why do you need a PBX then? I mean, you explained that it pretty much can do everything
because
that PBX
the call comes in, right? Someone needs to answer. Like if it needs to go to voicemail, if it's auto attendant.
Yeah, but you just said it's a registrar and it does the call routing.
Okay, you have a registrar, and then let's say a SIP phone wants to listen to its voicemail. Where is the voicemail? It's in the PBX. So someone needs to play. All the telephony features are in your PBX. Like voicemail, conference, what's that? Media playback. You call, like let's say phone A calls phone B, right? You dial 4123. So it has to go to your PBX, and then PBX says, okay, phone B right now is in do not disturb, send it to voicemail. Oh no, it is, ring it, and if it's not reachable, all find me, follow me features, all your telephony features are in your PBX. It's IVR and all that.
Thanks.
My question is, with a redundant, a proxy server redundant, how do you distribute the call between those redundant active situations?
Okay. So carriers, when you give your carriers your IP addresses, you can tell them I have 5 proxy servers. You give them 5 IP addresses, and then you can also specify how you want your calls be distributed to your proxy servers. You can say do round robin, do wait load balancing, do primary failover. So that's how your carriers would work. That's how your calls would be distributed through your OpenSIPS servers. What if you have what? If you have what? Sorry. No, if you have one IP address, then one IP address can only be assigned to one server. No, you can, if you have one IP address, then it would be active failover. So if one goes down, you would use virtual IP address, right? Use heartbeat and VoIP. So if one goes down, the other one takes over the IP address. You cannot send, then you would have another proxy server there that has that one IP address and do load balance to these 5 proxy servers. And some companies actually do cascade proxy servers. Like the first proxy server only does security check and some back-to-back user agent, and then the next series of proxy servers, they do all the rest of the features. That's also a possibility. Any other question?
Is there any type of API you can like listen on these to get events, like certain, if you want to put your CTI against your proxy rather than your Asterisk servers?
Good question. Yeah, there is OpenSIPS. There is an event interface module, so you can register for events, and you can get events. There is event routes, or in your script you say if this event happened, run this function, so to speak, and then like write something to database or call something. There's also the management interface. So like for instance, you want to see like a CLI, so to speak, similar to CLI in FreeSwitch, but it's not a CLI. But you can run commands to get reports. And then there is OpenSIPS CP or control panel project, which is a GUI for OpenSIPS. So you have all these, you can do everything through the GUI for all the modules. Then I have there's one person at the corner there.
Can you talk a little about the security vulnerabilities? We learned a lot about how easy is it to find out the Asterisk exploitations and do fraudulent calls and stuff like that. Can you, in contrast, talk about the security vulnerabilities that OpenSIPS might have and how to prevent them?
So there are, security is a never-ending story. There's various ways that you can get hacked, and there's various ways you can get, you can try to protect yourself. The easiest, one of the things that I always use, look at your network and see what's specific to your networks. Like if you're a company that only sells Yealink phones, look at user agent and says if it's Yealink, then if it's not Yealink, then right away drop the packet, because you know, the hackers don't know that you only sell Yealink. The hackers only scan the IP addresses. Or if you talk to carriers or you know, other gateways, always check the source IP address. Again, the hackers don't know which IP addresses work well, unless if the hacker is one of your employees, so to speak. So it always based on your specific environment, you can add different logic to your proxy servers to distinguish if this is a legit packet. There are other tools like fail to ban. If you've heard of fail to ban, it links with OpenSIPS. So if it has a database of, you know, all the malicious IPs and things like that, so if someone gets attacked, they update the database of all their location, sort of. But if you're try to not make your environment fully open, always keep it fully closed and then open only for specific. If you know all your customers, then only allow the those IP addresses. But if your customers are not mobile, but if they're mobile, then look for different things. Examine the domain. If they're registering with the same domain, because the hackers out there, they don't know your specific design. They might not even know your company. They just scan the IP addresses, and then as soon as someone responds, they start attacking. So, and if you see a malicious invite, don't say 404 not found or 503 service unavailable, because then all of a sudden they know, no, there is a SIP server there now. Just drop the packet, do not respond. The last one, yes.
Can you give us some features that are unique to OpenSIPS and make it distinguishable from other SIP proxies like Avail or things like that? What are the features that are unique to OpenSIPS and will make me, you know, to choose it over other SIP servers?
Right. So load balancer module is unique to OpenSIPS. Like Camellia has a dispatcher module, which it's not. Dispatcher module is slightly different. It does round robin or just sends a call to a server, but it doesn't know how many active calls are in each server. But load balancer, it keeps track of the active calls. You know how many calls are on each server. You can also assign resources and things like that. There is call center module that does queuing. So you can do a call center, or you can support queue feature. So you assign agents and skills, like some can do info, some can do technical and things like that. And then there are a few other things that I have to think about it, but things like that. But they're fairly close. It's not that like that, because they were both from OpenSIPS. Okay, thank you everybody. And if you have any questions, let me know.